Hi, welcome to EC252 lab1 tutorial. I would like to start with an introduction of a very important principle of data analysis, which is to keep track of any changes you make to data. First, this can be achieved by keeping a log of everything into its data. It is a good practice to open a log at the start of every session. You need to know how you arrived at a particular result and be able to reproduce it exactly if needed. Second, instead of saving changes to the dataset itself, you could implement all manipulations using two files. This will prevent from accidentally making a mistake and then saving your data, which could later lead to incorrect conclusions and spread mistakes into future work. In summary, keep log of everything and use two files. The log files are useful to keep a record of everything that appears in the results window. This includes both the history of commands and the history of outputs. To open a log, we type log using, and we're gonna name the file as EC252 lab1, comma, replace. If you specify the file extension as log, the log will be recorded in text format. If we type without extension, the default is to write file in SMCL format. Which extension format you want to use is a matter of personal choice. However, one thing to note is that normally you can access SMCL file using Stata only. Here, option replace replaces the existing log file with the same name. Note that options must be preceded by a comma. If you want to know the status of logging, you can type log without arguments, and the output here tells us that the logging is on. Next, we're going to open a do file. A do file is simply a text file that contains a sequence of Stata commands. Stata interprets them exactly as if they are entered in the command window. This becomes useful when you want to repeat the entire piece of code or want to add minor modifications. There are several ways to open, view, and edit do files. I'm using Mac version of Stata, but this is also applicable to the Windows version. Using the menus, go to Window, Do File Editor, and New Do File. We can also click on the notepad icon below the menus. Alternatively, type do edit in the command window, and each of these will open in the do file editor. Once the do file is open, you can start entering codes. So we're going to type our first command, log using EC252 lab1, and replace. Before you load or save files, you may want to change to the right directory for the data files. And by directory we mean folder. One way of doing that is under the File menu, choose Change Working Directory, and then select the appropriate folder. Alternatively, you can use Stata's cd command, followed by the directory. And what cd command does is that it changes the current working directory to the specified directory. To display the path of the current working directory, we can type pwd, and the output tells us that the current working directory is shared. Next, if we want to create a new directory, we can type mkdo command, followed by the new directory name. So we're going to name the new folder as EC252 Stata Lab. And next we're going to change to this new directory by typing cd EC252 Stata Lab. Okay, next we need to open dataset. There are various ways of entering data into Stata. The method used will depend on the available data. Here we have the data that has been saved in Stata data format. The dataset is available online. One way of entering this dataset into Stata is to save it on your M drive first. I have stored the data on my drive already, and it can be loaded with the command use, and the path to the data is, you might have different path name. In my case is users, shared, and the name of the data file. Okay, on the right here you can see that the data is loaded. Note that without the option clear, Stata will refuse to load new data if the old data hasn't been saved. Also note that if you use option clear, the old data will be lost unless it has been saved. By the way, most of the commands used in this exercise can also be accessed through the file menu. However, for learning purposes we will not use the menu commands, since executing commands through the command window gives much better control and allows for much faster and more exact working process. Okay, so let's get started with the first question. One of the commands used to examine the data is the command describe. This command provides technical information about all variables in memory. So this part of the table tells us that there are 1260 observations and there are 15 variables. This part over here displays labels of all variables, and if we look at the label of variable edu, we can learn that this variable is yearly education and wage is hourly wage. Labels are designed to provide additional information that is not apparent from the variable name. Sometimes the variable name itself will be self-explanatory. For example, the meaning of the variable wage is obvious, although we don't know the unit of measurement. It could be hourly, monthly, or yearly wage. And for some variables, it might not be so obvious, as for these variables we have here. Labels are very useful, especially when we're dealing with binary variables. For example, consider binary variable female. Let's browse female. We can see that observations can take only two values, 0, 1. Without a label, we would have trouble knowing which refers to male and which refers to female. So if we look at the label, we know that if the observation takes value of 1, it is female, and if it takes value of 0, it is male. Therefore, it is a good practice to label your variables. Summarize is another command to examine the data. We type summarize, and the output displays for all variables in memory the number of observations, the mean, the standard deviation, the minimum, and the maximum. This command can also be restricted to a specific list of variables. So we type command summarize followed by wage, and it will return summary statistics for that variable only. The output tells us that the mean wage is 6.3, standard deviation is 4.6, the minimum wage is 1.02, and the maximum wage is 77.72. Stata has an inbuilt help function. In fact, you can easily access the help file for any command. For instance, if we type help followed by any Stata command, in this case we type summarize, it will provide a help file for that command. What we see here is the general structure of the inbuilt help file. The title tells you what the command is and what it does. Here the command is summarize, and it provides summary statistics. Then it gives the syntax, which is simply a structure of statement for Stata to implement. So it says summarize var list, which is a list of variables, if, in, and wait, followed by comma options. If and in qualifiers allow you to subset the data by using only the observations specified, and wait allows you to weigh your data in different ways. We're not going to deal with weights and in qualifier in this exercise. However, later we will see how if qualifier can be used. So options for the summarize command are listed here. So the first one says detail, and what it does is display additional summary statistics. Let's see how this option works. We type summarize, wage, comma, detail. So now this command provides more information for the variable wage, such as percentiles, the mean, and other information. We need information on these percentiles. So the 5th percentile of the wage distribution is 1.98, the 10th percentile is 2.31, the 25th percentile is 3.705, 75th percentile is 7.7, 90th percentile is 10.295, and the 95th percentile of the wage distribution is 13.25. Another thing to note is that Stata commands can generally be abbreviated to save typing. If we go back to the file, we could see that S and U are underlined in summarize command and D is underlined in detail. This means that you don't need to type anything more than SU for summarize and D for detail. So we can also type SU wage, comma D, and this gives exactly the same output. However, in my do files, I like to use the full name of the command as it gives a better understanding of the commands you are using. Graphs are a powerful tool for exploring, summarizing, and presenting your data. To investigate the distribution of a single variable, we can construct a histogram using the histogram command. For example, in this case, the variable of interest is wage, so we type histogram, wage, comma, name, open brackets, hist1, comma, replace, close brackets. And this produces the histogram of the wage. Okay, we used name option, which specifies the name of the graph being created. In this case, we named our graph as hist1. And we used suboption replace in order to discard previously created graph with the same name. If there's no graph in memory with the same name, then we don't really need to type replace. However, if a graph under that name already exists, then without replace suboption, Stata will refuse to create a graph. To draw histogram for the wages between 5th and 95th percentile, we can use information from previous output. So the wage associated with the 5th percentile is 1.98, and for the 95th percentile is 13.25. So we type histogram, wage, if wage is greater or equal to 1.98, and wage is lower or equal to 13.25, comma, name, and we're going to name our graph as hist2, and replace. So this produces the histogram. where we instructed Stata to use only observations for which the wage is greater or equal to 1.98 and wage less or equal to 13.25. Okay, in order to investigate what the option normal does, let's type histogram wage. If wage is greater or equal to 1.98 and wage is less than or equal to 13.25. We're going to use norm and let's name our graph as hist3 and replace. So option normal specifies that the histogram be overlaid with an appropriately scaled normal density, which will have the same mean and standard deviation as the data, and this will allow us to have a good visual comparison of the normal distribution with the distribution of our data. Another useful command for presenting the main points of your data is tabulate, which produces frequency tables for numeric variables. However, this command is likely to be more useful for variables with relatively few entries, such as categorical data. Typing tabulate female produces one-way frequency table for binary variable female. So there are 436 female workers in total. And to know the proportion of females working in the service industry, we type tabulate female followed by service. And it produces a two-way cross table for two binary variables, female and service. This gives a breakdown of a variable female by service. For example, it shows how many male and female workers there are in each industry. And to find the proportion of females working in the service industry, there's a helpful option row. So we're going to type tabulate female, service, comma, remember that options are preceded by comma, and we type row. And this displays the relative frequency of each cell within its row. So 43.89% of females work in the service industry. And also note that there's a key at the top left corner which tells you what each of these numbers stand for. So the top number represents frequency and the bottom is row percentage. Also note that the layout of the table will depend on the order of entry. For example, if we enter service first, followed by female, so we type tabulate service, female, then the variable female will appear at the top of the table. So in this case, to find the relative frequency of female workers within service industry, the appropriate option here would be col, which stands for column. So we type tabulate service female, comma, col. And the output displays the relative frequency of each cell within its column. So here we have the same proportion, which is 43.81. We type tabulate black, and the output tells us that the proportion of black individuals in the sample is 7.38%. We need to use two-way frequency table, so we type tabulate black female, and there are 50 black women in the sample. In order to know the proportion of black women working in the service industry, we type tabulate black female if service equals to 1. So we're instructing Stata to produce a two-way table for variables black and female only when the variable service takes value of 1, that is, when the person works in the service industry.